Well, I want to talk to you about this man, Gottlob Frege. And I bet that most of you would never have heard of him before, at least those of you who don't know much about mathematics or philosophy, because in terms of reputation, he's a singularly obscure person. However, he's the most important person in the history of 20th century thought, and his story is a fascinating one. So I'm going to try and tell it to you tonight. Okay, so first of all, that's his history. As you can see, I mean, he didn't live a terribly exciting life. Born in 1848, studied at Jena and Göttingen, professor at Jena all his professional life, and he died in 1925. Frege was a mathematician, and he worked on the foundations of mathematics. That is, roughly speaking, that area where people investigate the basic concepts of mathematics, how they function, what's true of them, and so on. And he worked for something like 20 years on his magnum opus. No publish or perish syndrome then. This was the Grundgesetze der Arithmetik, in which he formulated and justified his views about these basic concepts. And I'll try to explain this to you as we go along, but let's just give you the big picture first. So the first volume appeared in 1893, and the second volume was just about to appear in 1903, when, as the book was in press, Frege received a letter from this man, Bertrand Russell. And Bertrand Russell, the great British logician, had been reading Frege, and he'd found a problem with Frege's work. And Frege was devastated by this. So he wrote back to Russell in the following terms: "Your discovery of the contradiction caused me the greatest surprise, and I would say, almost say consternation, since it's shaken the basis on which I intended to build arithmetic." That's theory of numbers. "The matter's all the more serious, since with the loss of the principle in question, not only the foundations of my arithmetic, but also the sole possible foundations of arithmetic seems to vanish. In any case, your discovery is very remarkable and will perhaps result in a great advance in logic, unwelcome as it may seem at first glance." So after he got the letter from Russell and he replied to it, he ripped the book off the press. And he thought for a while, and he added an appendix in which he tried to repair the problem that Russell had found. And the appendix starts like this: "Scarcely anything more unwelcome can befall a scientific author than to have one of the foundations of the edifice shaken after his work is done. This is the position into which I was placed by letter of Mr. Bertrand Russell, as the printing of this volume was nearing completion." So, in the body of the appendix, he tried to solve the problem that Russell had found, and he made some suggestions. But it must have been very clear to him very soon that these didn't really work. And effectively, he gave up the project. He didn't stop publishing quite. He did publish some things after that, but effectively he gave up his life's work. And he did think a bit more about the foundations of mathematics, but it was on a completely different way, which never came to anything like fruition. So Frege realised that his magnum opus had gone down the gurgler, and he died in 1925 believing that his life's work was a failure. However, few people managed to create a revolution in thought, but actually Frege did that. He created a revolution in logic. But he created not only one revolution in logic, he actually created two revolutions. He also created a revolution in philosophy. So his work in both logic and philosophy in the 20th century is seminal. Okay, so this is where we're going. First of all, I'll explain Frege's work to you and why it ended in failure. Then we'll see how he managed to bring about these two revolutions, which he really had very little conception of because he died in relative isolation. And now I'll just say a few more words about the conundrum, which is Frege. So, first of all, Frege's failure. And to explain the failure, I have to explain to you the context in which he was working. So this is the foundations of mathematics in the 19th century. So in the 19th century, people knew there were lots of different kinds of numbers. There are natural numbers, 0, 1, 2. There are integers, which is, those plus the negatives. There are rational numbers, fractions if you like. There are real numbers, things like root 2 and pi and so on. There are complex numbers, like the square root of -1. And there were infinitesimals, numbers which were closer to 0 than any real number you like. So there's this whole welter of different kinds of numbers. And people didn't really understand them at all. So real numbers, or irrational numbers, had been discovered by the Greeks, but the Greeks didn't know how to handle them. And some 2,000 years later, the situation wasn't any better. People had no idea what a real number was, how to manipulate it properly. And these guys were even worse, because they appeared to have contradictory properties. So the foundations of mathematics in the 19th century was a real mess. But what mathematicians did, and most of them were German, it must be said, was introduce rigour into the foundations of mathematics for the first time and tried to give a rigorous account of these notions. So the first thing that happened was that this guy, Weierstrass, got rid of infinitesimals. So that was probably the biggest problem out of the way, but that left all the others. But a whole series of German mathematicians tried to explain the other kinds of numbers. And roughly speaking, what they did was this. Complex numbers they analysed as pairs, a certain sort of set of real numbers. Real numbers they analysed as sets of rational numbers. Rational numbers they analysed as sets of pairs of integers, and yes, I mean that. Integers they analysed as pairs of natural numbers, and that left just natural numbers and sets thereof. So you see, the whole thing had been reduced to numbers, natural numbers and sets. And I'm not going to go into the details here because they'd be boring, but let's just show how one of these tricks is turned. That's the definition of real numbers. Okay, so this was done by Richard Dedekind. And his solution to what a real number is very, very simple. Just take a sequence of rational numbers, fractions. Okay? Those can be ordered in the obvious way. Now partition them. Okay, so it's two parts such that all of these guys are less than all of these guys are greater than all these guys. Well, Dedekind said, that's a real number. Just a pair, just a section of rational numbers. It's very simple, but very effective. So root 2, for example, everyone's favourite irrational number, is just that partition. And you see, because root 2 has an infinite decimal expansion which never repeats itself, there's no last member of this partition and no first member of that partition. So there's a kind of gap, as it were, but you can represent this gap by this partition. Okay, so that's the Dedekind trick. And in the same way, by the time that Frege was working, all kinds of numbers had been defined in terms of sets and natural numbers. And there things stood. So the next question on the agenda is, what the hell is a natural number? What is 0, 1, 2, 3, 4? This was the problem that Frege set himself to work on. And what he wanted to do was define the natural numbers in terms of sets, so reducing everything just to sets. And then he wanted to say that the principles about sets are really principles of logic. So in this way, he'd have reduced all of number theory to pure logic. And this was his thesis, called logicism. All truths about numbers are truths of pure logic. Okay? So, 2 stages. Define the natural numbers in terms of sets, and then show that sets are part of logic. That was Frege's program. Okay, the first part is kind of easy. That's the definition of natural numbers in terms of sets. So roughly speaking, Frege said 0 is the set with no members, 1 is the set of all sets with 1 member, 2 is the set of all sets with 2 members, and so on. Now, of course, that's circular as a definition. That doesn't work. But roughly that's what it amounts to, and part of Frege's cleverness was he was able to do that without circularity. So that part was sort of under control. What about sets, though? He had to show that sets were really part of logic. So what is a set? Well, Frege said that a set is really just the extension of a condition. So any condition you can put on things, whatever is the bunch of things that satisfies that condition, is a set. So any condition defines a set. A set just is the extension of a condition. So, for example, the condition is red defines a set of red things. The condition is an even number defines a set of even numbers, and so on. It looks kind of straightforward, right? And having taken, or thought that sets are just sort of the extensions of any condition you like, conditions look pretty much like things that belong to logic, so is home and hosed. So this was his program, and this was what he set out in the Grundgesetze, his magnum opus. So what was the problem that Russell found with this? Well, it was to do with Frege's account of sets. So some sets are members of themselves. So, for example, the set of all sets is a set, and so it's a member of the set of all sets. So that set is a member itself. Some sets are not members of themselves. So the set of red things is not itself red, it's an abstract object. A fortiori, it's not red. So the set of all red things is not red, so it's not a member itself. Okay, so some sets are, some sets aren't. What about the set defined by the condition is not a member itself? So think of all those sets which aren't members themselves, like the set of all red things. Is it a member itself? Well, if you just think about it for a moment, if it is a member itself, then it's one of the things that isn't a member itself. And if it isn't a member itself, well, it's one of the things that's in the set. So if it is, it isn't, it isn't, it is. That's Russell's paradox for you. And that's the paradox that Russell found which destroyed Frege's work. Okay, and as I said, his work never really recovered from this because he had no solution to it. And the solution nowadays, I guess, is still contentious in some ways. So it wasn't the only paradox that was turning up at this time. So there were various other paradoxes, for example, by Cantor, one of the foundation figures of modern set theory, about this biggest set. Okay? Think of that biggest set. The biggest set of everything there is. Okay, well, Cantor actually proved that for any set there's a bigger. So there can't be a bigger set, yet the set that contains everything has to be the biggest set. So this is actually of a piece with Russell's paradox, although that maybe not be obvious. But filling in the details is hard. It takes pages and pages of mathematical work, and so people didn't quite know how to react to it. But Russell's paradox, you can explain to a 10-year-old, okay? That's what made it hard, because it was clear that the problems weren't just in the kind of recondite machinations. They were buried deep in the conceptual apparatus that was being deployed. All right. So, you might just want to know what the situation is nowadays. The modern situation is essentially due to this guy in the 1910s, 1920s, Zumelo. And Zumelo showed how numbers can be defined purely in terms of sets. It wasn't Frege's definition, because that became impossible. But Zumelo found another way to do it. So, in a sense, that part of Frege's program was carried out. You could define natural numbers in terms of sets, but the set theory turned out not to be part of logic. And in particular, you had to give up this idea that every condition defined a set. So some do, some don't. And crucially, that kind of condition that you use in Russell's paradox turned out, according to Zumelo, not to define a set. Which conditions define sets, which don't? Well, that turns out to be a really hard question, and whatever it is, the answer doesn't look like pure logic. It looks like there's a lot of hard mathematics going on there. So that's the kind of current situation, and maybe a little bit of Frege's program was salvaged, but not the whole thing. Logicism has gone out the window. Okay, so that's the revolution in logic. So it's not the revolution in logic. That's Frege's magnum opus and why it failed. Okay, but as I said, even though his major projects in life failed, his work generated two revolutions, one in logic and one in philosophy, and I'll describe those to you now, starting with the revolution in logic. So why did Frege need logic? Well, he needed logic because he wanted to show that everything in number theory was logic. So you write down some basic axioms, if you like, or conditions which are logic, and then you want to deduce everything else from that. So you need some kind of inference engine, some kind of machinery which allows you to deduce other things. And Frege was living in the 19th century with the high standards of German rigour in mathematics, so there could be no hand-waving. This had to be tied down really hard. And what Frege discovered was that traditional logic just wasn't up to the task. So logic has a long history in the West, and it has gone through 2 or 3 great periods in the last 2,500 years, but it goes back to this guy, Aristotle. And in some way, Aristotle's work remained foundational until the end of the 20th century, until Frege, that is. So what Aristotle did was canonize a system of inference which is called syllogistic. And here's a simple syllogistic inference, which you may have suffered under in some intelligence test or other. All A's are B's, all B's are C's, therefore all A's are C's. Well, that looks kind of right. If all A's are B's and all B's are C's, well, then anything that's an A is a B. Here's another one. Some A's are B's, no B's are C's, so some A's are not C's. That's harder, isn't it? Okay, I'll leave that one as an exercise for you. You can sort of take it home and scribble with little circles and things. You'll see it works. Logicians knew about this kind of inference. The trouble is that the ones you really needed to carry out Frege's project and to do the kind of mathematical deductions that Frege was interested in just were much more complex than anything in Aristotle's syllogistic. So you need to do things like this. This is, roughly speaking, a proof there's no greatest prime number. What you do is it's an argument by reductio ad absurdum. You suppose there is, then you deduce something which contradicts it, and then you infer that the assumption must be false. So suppose that n is the greatest prime number, then you do a bit of deduction. So there's an m greater than n, which is also a prime number. And that can't be right if n is the greatest prime number. So the supposition can't be right. There's no greatest prime number. So that's a simple reductio argument, standard argument in mathematics, but you just can't formalize it in syllogistic. And as Frege started to work through the details of the deductions he wanted to make, he just realized that Aristotelian logic of his day was not up to scratch. So he needed a new vehicle to do this. And so he invented what effectively amounts to modern logic. Okay, and he did this, because he was a mathematician, in a way that deployed the mathematical techniques of his day to logic in a way that never had been done before. So in particular, mathematicians at the time were developing techniques of algebra, axiomatization, and that's exactly what Frege did to logic. He deployed these techniques to produce logic approached in this fashion. So this was in his first book called the Begriffsschrift. It means the concept notation, which he published in 1879. So it's here he created the logical vehicle for what he wanted to do. And if you look at what he created, you will see funny things like this. Now, this is not Frege's notation. I'll come back to that later. This is the notation as it appears in modern logic. And you can see that it's symbolic logic. This is actually a list of axioms for Frege's system, or at least a large part of it. And then you deduce things by manipulating those symbols. All right. So he deployed the techniques of algebra to do this. But he had to do a lot more than that, because he had to make many conceptual innovations to handle things for the first time, really, in a way that no one had ever thought about before. So, just think of those sentences. Alice saw Brad and Alice saw someone. Now, they look as though they're kind of similar, right? Alice, in both cases, is seeing something, and it's sort of definite in the first case and not very definite in the second. So, someone is a bit like a name. It's a bit like Brad. It ain't. Because as soon as you start to think about this, all hell breaks loose. It's not so obvious with someone, but it's obvious with Alice saw no one. Okay. In Lewis Carroll, he has a great deal of fun with this. So Alice meets the White King, who's looking for a messenger. And the White King asks Alice whether she's seen anyone come down the road, the messenger. And Alice says, I've seen no one. And the king says, just look on the road and tell me if you can see the messenger. I see nobody on the road, said Alice. I only wish that I had such eyes, the king remarked in a fretful tone, to be able to see nobody, and at such distance too. Why, it's as much as I can do to see real people in that light. Okay, this is a Carroll joke. His works are replete with philosophical jokes, and the king is kind of treating nobody as a name, and it obviously isn't. It's just a way of saying you can't see anybody. So these words like everyone, someone, no one are not names. So how do you treat them? Well, this was a problem that had kind of lain dormant in logic for 2,000 years. The medievals had a very, very cunning way of treating phrases like this by sort of reducing them to names. It sort of worked, but not very well. So Frege had to invent a whole new conceptual apparatus to handle this kind of thing, because phrases like something, everything, nothing are just, everywhere in mathematics. So what he did was say, well, we need to recognise some new linguistic categories, and he called them quantifiers. So this one with the upside down A is read all x are such that. So for all x, just you read that as all x are such that, and this one with the backwards E is read as some x such that. Okay. And then, if you've got that machinery under control, you can write the two sentences we started with like this. So, Alice saw Brad. Brad is a name, no problem. Okay? But Alice saw someone says, for some X, Alice saw X. And now it's quite clear that the form of these two things is quite different. Right? And once you make these conceptual innovations, lots of things become clear. So everyone saw someone has two quantifiers, everyone and someone. And it might not ever have struck you before, but that's actually ambiguous. It can mean there's somebody such that everybody saw them, same person, or it can mean everybody saw somebody or other, maybe different people. So, for example, suppose I say, we're all waiting on the road, we're waiting for the messenger to come, the road was empty, and suddenly everybody saw someone. Now, the natural understanding of that is everybody saw the same person, the messenger. Right? But if I say, we were very busy at the open day, everyone in the staff worked, no one shirked off, everybody saw some student or other. Okay? That doesn't mean that everybody saw the same student. That means that everybody saw some student. So that's an ambiguity in this. And this is an ambiguity which you get quite naturally once you realise that there are quantifiers involved. So this says that for every x, there's a y that x saw y. So that's every x saw some y. That's like the student case, right? This says there's some x such that everybody saw, there's some y such that everybody saw the y. That's the case where everybody sees exactly the same person. And before you run away with the idea that this is a party trick, it most certainly isn't. The order of quantifiers is really significant as soon as you start to do any reasoning of any complexity. So one thing that threw mathematicians badly in the 19th century was this. Okay, the first one is a condition for continuity of a function, and the other is a condition for uniform continuity. Now, I'm not going to try to explain to you what the difference is, but they're different. Continuity is roughly when you can draw a curve without taking your pen off the paper. Uniform continuity when it's a lot smoother than that in some sense. And the difference between them, which had really thrown mathematicians for 100, maybe 150 years, is precisely in this quantifier switch. You can see that they're exactly the same, except for the fact that this one has a universal and a particular, and this one has a particular and a universal. That's the only difference. But because people didn't have this straight, they were really confused. All right, so what did Frege's revolution in logic amount to? Well, it amounted, in effect, to the discovery of modern logic with its conceptual innovations, such as quantifiers. Now, Frege's innovations caused a major upheaval in mathematics and logic and computer science in the 20th century. So this guy, David Hilbert, maybe one of the greatest mathematicians of the 20th century, took Frege's work. Well, not quite, I'll come back to that in a minute, but essentially Frege's work, made it more rigorous, developed the idea of a formal system, and proved a number of significantly important results in what is now called mathematical logic. Well, him and his school, and the people who were influenced by him, one of them was this guy, who's doing a dead ringer for Morticia, I think. That's Kurt Gödel, who proved one of the most profound, I think, theorems in 20th century mathematics, usually known as Gödel's incompleteness theorem, which I'm not going to try to explain to you, but if you ever heard anything about mathematical logic in the 20th century, you will know that his theorem was amazing. Okay. Not only that, this guy, Alan Turing, one of the most important founders of computer science. So this is 30 years before the advent of physical computers. People like Turing laid down the foundations of computational science 30 years before practical computers appeared. This is an amazing achievement. And this guy was spinning off the work of Frege and Hilbert. So logic is used in computers in many ways at many levels, but one thing computers do is manipulate symbol systems. And that's exactly how Frege conceptualized logic. And that was the way that Hilbert developed the idea. So, none of these developments in mathematics, in computer science, would have been possible without Frege. So he really did initiate an enormous revolution. Moreover, if you open any logic first-year textbook today, you will see essentially Frege's work. Here's one by my colleague Greg Restall. It's a first-year book on logic, and in it, Greg explains essentially Frege's logical theory. So this is absolutely orthodox in modern logic. It just couldn't be there without the work of Frege. So it's much harder to track, but nonetheless, it's clearly there. So let me talk about the revolution in philosophy. It's kind of a truism amongst people who know about 20th century philosophy that it's marked by something called the linguistic turn. And what that means is kind of contentious, but it means that for the first time, really, in the history of philosophy, philosophers started to worry about the way that language works. And indeed, the analysis of the way that language works becomes absolutely central to how philosophy is managed in the 20th century. People disagree about how it works. People disagree about how to manage it. But if you look at all of the great traditions of philosophy in the 20th century, they're all kind of, the philosophy of language is absolutely key to them, whether it's the logical positivists, whether it's deconstructionists, whether it's Oxford ordinary language philosophy. The way that language functions is absolutely central to philosophy in the 20th century. Whether we're through that period now, who knows, it's too soon to tell. But it's certainly true of the 20th century. Now, it was not like that before Frege. So the relationship between thought and reality is a traditional philosophical problem going back 2,000 years. And people worried about the relationship between thought and reality. Is reality independent of thought? Or does thought, in some sense, help construct reality? These are standard debates in philosophy before the 20th century. But what Frege did was say, hang on, you can't just think of it as a two-way relation. You've got to think there are three things which are really important here, not just thought and reality, but language as well. And you're never going to get this relationship straight unless you get these relationships straight as well. So Frege put the analysis of language squarely on the philosophical map. So he's, in a sense, responsible for the linguistic turn in philosophy. Now, it's a bit more complex than that, and I'll come back to that, but let me just explain how Frege got to do this, why he did this, and what he did. So Frege was not a philosopher, but he came to appreciate the necessity of understanding how language works precisely because he was driven to understand the difference between a name and a quantifier. And the more he started to think about the way that language works, the more he got into a serious articulation of the function of language. And I think it's fair to say that Frege was the first person in the history of Western thought who produced a sustained and rigorous analysis of the way that meaning works in language. So this guy is 20 years before Saussure, let alone Chomsky. And what Frege did was done in just a couple of small papers. So unlike the big book, he wrote a number of small papers on the way that language works. These are two of the most important. Über Sinn und Bedeutung, on sense and reference, and über Begriff und Gegenstand, concept and object. So these were some of his key linguistic semantic categories. So let me explain those to you. First thing about Frege is he said that subjective mental states have nothing to do with meaning. Now, in this, he was going right against the grain of whatever traditions there were in the philosophy of language before that. Because the people who talked just a little bit about meaning before Frege, like Locke, thought that the meaning of something is just the mental image it conjures up in your mind. And that's crazy, Frege said. And this is, nearly every philosopher of language in the 20th century has followed Frege down that path, meaning whatever it is has not got anything to do with the image in your head, which may or may not be conjured up when you hear the word. So you've got to give an analysis of language which avoids appeal to subjective mental images. Okay, well, let's look at a couple of Frege's insights. So take these two sentences. The morning star is the morning star. The morning star is the evening star. Now, both those are true, okay? And because the morning star is the evening star, well, then the object referred to on the right-hand side of both those equations is identical. However, that one seems kind of trivial, right? Everyone knows the morning star is the morning star. That the morning star is the evening star was presumably a substantial astronomical discovery by the Babylonians or whoever it was, I don't really know. So how come these things can be so significantly different when the thing referred to on the right-hand side is the same thing? Well, Frege said, you've got to distinguish between the meaning, the sense, and the thing referred to. So the morning star and the evening star have the same reference, they refer to the same thing, but they have different senses. Where the sense is something like the mode with which the object is presented. So it's a kind of conceptual route, as it were, to get at the object referred to by the name. So that sense and reference, that's one of Frege's crucial distinctions. The other is between concept and object. Take this sentence, Alice is happy. Now that's a perfectly fine sentence, right? What about this one? Or those two? Alice Brad, not really a sentence. Is happy is sad, not really a sentence. So you can't just get a sentence by splicing together any two old phrases. You've got to have a noun phrase and you've got to have a verb phrase. But how is it they function together to produce a single thing, namely the thought that Alice is happy? How, do the parts fit together? I mean, obviously they do fit together, but what does it mean to fit together in this way? Well, Frege said that Alice refers to an object, and is happy refers to a quite different kind of thing, namely a concept. And concepts are completely different from objects. Concepts have gaps in them in some metaphorical sense, and that the reason that Alice is happy fits together is that you've got a concept with a gap in it, and along comes the object and it fills the gap. So we have a kind of metaphysical distinction between two quite distinct kinds of things, objects and concepts. And they must be radically different, their behaviour must be radically different, otherwise you wouldn't be able to explain how come some things fit together and some things don't. So Alice Brad doesn't fit together because Brad hasn't got a gap in it to be filled. And is happy is round doesn't fit together because is round's got a gap in it, but is happy is not the kind of thing that can fit it. So if you put this pair of dichotomies together, you get a very general picture. And in its simplest form, it looks like this. Consider noun phrases and verb phrases. They refer to different kinds of things. Noun phrases refer to objects, verb phrases refer to concepts, and that's their referent. But all words have not only a referent, but a sense. And what is the sense? Well, in each case, the sense is the mode of presentation of the object or the mode of presentation of the concept. Okay, so this is sort of the guts of Frege's philosophy of language, or theory of semantics in a nutshell. And, although it may not be obvious to you, that gives you an account of the metaphysical structure of reality. So you might have thought you were doing semantics here, and you are, but in fact it involves a kind of metaphysical taxonomy of the kinds of things that there are in reality. And what Frege said is, hey, there's at least different kinds of things in reality. All right. So we'll come back to that in a minute. But this was Frege's theory of semantics in a nutshell. And it didn't have the effect that his logic had. So as I explained to you just now, the logic has become entirely orthodox. You open any first-year textbook, you will find Frege's logic. This is not true of his theory of semantics. Virtually no one will accept Frege's theory of semantics now. In fact, there really isn't much consensus on semantics at the moment. There are still a number of very different schools which argue about how semantics works. So Frege's effect was not to make a view canonical. Frege's effect was to put the theory of meaning centre stage so that his work was taken up and it was deployed by subsequent thinkers inaugurating the linguistic term. Now, Frege, of course, was not the only philosopher who was instrumental in causing the linguistic turn. This one is another one, Edmund Husserl. So, Frege and Husserl are both end of the 19th century thinkers whose work, above anything else, has served to define 20th century philosophy. And they are both responsible for putting philosophy of language right at the centre of things. But Husserl was a little bit younger than Frege, and in fact, Husserl's first book was on the philosophy of arithmetic, a kind of thing that Frege was interested in. And he published this book, and it drew a quite very severe rebuke in a review from Frege, who pointed out a number of the problems with it. At this time, Husserl was still working with the idea that you can think of numbers as kind of mental entities, subjective mental images, and Frege was already dead against that. So Frege published this critique of the first book by Husserl and made Husserl change his mind. So in his next book, Logical Investigations, Husserl completely rejected the psychologistic ideas that he'd had in his earlier book and went to work on something which got rid of all these psychological elements from his account of arithmetic. Now, he didn't reproduce Frege. He didn't rewrite Frege, but nonetheless, Frege's impact on him was immense. Both of them, Husserl and Frege, developed an account of meaning, but the accounts of meaning were quite different. For Frege, I've already talked about, he used his work in logic to develop a bunch of logical tools, whereas what Husserl developed was something called phenomenology. And phenomenology is an analysis of the objective structure of thought, not kind of fleeting mental images, but the objective structure that mental representations must have. That's why it's got something to do with meaning. So their solutions to the problem of meaning are very different. And interestingly enough, both of these have sort of gone their own ways since Frege and Husserl died. So this side has been very influential in English-speaking philosophy. This side has been much more influential in German and French-speaking philosophy. So, as some of you may know, there's supposedly a division between analytic and continental philosophy. Well, to the extent there's a division, this is kind of the branch point. Notice, though, that both these guys were, German-speaking. So its origins were in Germany. How come this took hold in the English-speaking world and this remained in the German-speaking world? The answer is, of course, complex, but there's one word which captures much of it, and that's Nazism. Because many of the guys who worked down this side of the street tended to be either Jewish or very left-wing. And, of course, they had a bit of a rough time in the Third Reich. So a number of them, at least those that weren't wiped out, said, we're off. And they emigrated. Most of them ended up in the US, and so they had most of their influence in the US. So this is how this conceptual division became a kind of geographical division as well, to the extent that it is. Anyway, I just wanted to point out that the linguistic turn was not... there are other people who are very much involved in the linguistic turn, like Husserl, but even in the case of Husserl, whose work in the end was very different from Frege, Frege played a crucial role in getting Husserl out of his original psychologism into what he eventually got into. Okay, so that's the two revolutions that Frege initiated or had a hand in initiating. One was in logic, one was in the philosophy of language. And both of these things have been absolutely dead central to 20th century thought, both mathematics, logic, computer science, and philosophy on the other. All right, now let me just say a few more words about the Frege conundrum. Because, as I said, one part of the conundrum is that Frege died thinking his life's work had been a failure. And so it was. I mean, you know, his magnum opus had crashed and crashed big time. But the tools that he developed along the way took on a life of their own, which I don't think he ever came to appreciate. That's part of the conundrum. But there's another part of the conundrum, and that's this. Frege was not translated into English until the 1960s. No one in the English-speaking world, in fact, no one in the world read Frege until, you know, some of the stuff was translated in the 1960s and 1970s. And by that time, these two great conceptual revolutions were well and truly, you know, underway and gone through. You know, they'd taken place by the 1920s, if not before. So how did Frege have this influence when no one read him? That's another part of the conundrum. Well, the answer is that his ideas were transmitted by other people. So let's take logic first. I'm sorry the picture's a bit grainy, but this is Bertrand Russell looking a bit older than he did in the earlier photograph. So Russell was working on ideas that were similar to Frege, 20, 30 years after Frege, or 10, 20 years after Frege. And he had the same idea as Frege, logicism. He had a different way of going about the project. It failed just as much in the end. But Russell read Frege and took up many of Frege's ideas. And it was through the work of Russell that people appreciated Frege's ideas. Now, Russell certainly is frank about what he's taken from Frege. But as is often the case, people don't go back and read the original, but they just, when they think they know the answer, they don't need to go back to the original. They just take whatever they need. And one of the reasons that people did not go back to Frege, who got quietly forgotten in the process, was because of the notation that Frege used. So his book was called the Begriffsschrift, called the Concept Notation, and it looks something like this. Oh, Principia Mathematica was Russell's work in 1910 when he espoused logicism. Forgot that, never mind. This is the Begriffsschrift, Concept Notation. And probably, unless you're a mathematician or a logician, this would look just as opaque as all the squiggles I put up before. But if you're a mathematician, there's a world of difference. Because you can see, I think, that Frege's notation is two-dimensional, whereas standard mathematical notation is just one-dimensional. Equations are written on a single line. And generally speaking, mathematicians and logicians find it much easier to read things which are written in one dimension, on a straight line, than two that cross the page. So this Russell's notation was not actually his own. He borrowed that from an Italian mathematician called Peano. But nonetheless, people couldn't read Frege. It was just too difficult to get their head around. And so it was actually Russell that had an impact on the subsequent developments in logic, not Frege, even though Russell himself was reacting to and taking over a lot of Frege's ideas. So it's Russell's work, for example, that goes into Hilbert's school, which is the direct line of transmission. So that's one reason why Frege's work wasn't really recognised. The acknowledgements were there for people to follow up, but they just didn't. Okay. The story in philosophy is really quite different. Frege's work in philosophy was transmitted not by Russell, but by this guy, whose name I would guess that most educated people know, Wittgenstein. And Wittgenstein was heavily influenced by Frege, in particular in this book, the Tractatus Logico-Philosophicus, which is one of the great classics of 20th century philosophy. And on another occasion we could talk about Wittgenstein, who's a much sexier figure than Frege, but in some sense that's not part of the story today. So Wittgenstein was very heavily influenced by Frege. But Wittgenstein, unlike Russell, didn't cite his sources. So, this is part of the introduction to the Tractatus. I don't wish to judge how far my efforts coincide with those of other philosophers. Indeed, what I've written here makes no claim to novelty in detail. Well, that's not true. And the reason why I give no sources is that it's a matter of indifference to me whether the thoughts that I have and been anticipated by someone else. I will only mention that I'm indebted to Frege's great works and to the writings of my friend Mr. Bertrand Russell for much of the stimulation of my thought. This is coy. Wittgenstein was heavily influenced by Frege, and it's only in recent years that the correspondence between Frege has come to light. But they had a substantial correspondence, which they didn't agree. I mean, the Tractatus is not Frege. Wittgenstein is different. But nonetheless, it spins off Frege's work. And this correspondence that Frege and Wittgenstein had was crucial into the formation of the Tractatus. And in fact, although Wittgenstein doesn't explain that, because he's not the kind of thing he does, it's clear to anyone with the eyes to see it that the metaphysical picture that you get in the Tractatus is really an attempt to work out some of the problems that Frege had run up against when he was working out his philosophy of language. So the Wittgensteinian distinctions between sense and reference, between saying and showing, between the various kinds of nonsense, these are all responses to problems that I haven't talked about that Frege found. So the Tractatus is a deeply inspired Fregean book, but Wittgenstein doesn't give his sources. So people read Wittgenstein and not Frege. But the Tractatus was indeed one of the most influential books in the history of 20th century philosophy. So Frege's influence in philosophy was not transmitted because people couldn't go back and read the original. It was transmitted because they didn't know really where to go and see. And it wasn't until the work was translated into English in the 1960s that people started to understand the kind of influence that Frege had had. So there are two conundrums concerning Frege. The first was the fact that his life's work ended in failure, and yet he caused two major intellectual revolutions. And the second kind of conundrum or irony of Frege's life is that the roles he'd played in these revolutions were not even recognised until 40 years after his death, by which time, the revolutions were well established. So, in some ways, Frege is a tragic figure. In some ways, he's an heroic figure. And there really aren't many figures of his status or calibre in the history of Western thought. Let me end by quoting a little bit more Bertrand Russell. The correspondence between Frege and Russell, which triggered the collapse of Frege's magnum opus, was itself not published until the 1960s. No one was interested in Frege until the 1960s. But eventually an editor wrote to Russell and said, well, look, we'd like to publish your correspondence with Frege. Will you give us permission? and the editor was a man called Van Heinold, and Russell wrote this: "I should be most pleased if you would publish the correspondence between Frege and myself, and I'm grateful to you for your suggesting this. As I think about acts of integrity and grace, I realise that there is nothing in my knowledge to compare with Frege's dedication to truth. His entire life's work was on the verge of completion. Much of his work had been ignored to the benefit of men infinitely less capable. His second volume was about to be published, and upon finding that his fundamental assumption was in error, he responded with intellectual pleasure, clearly submerging any feelings of personal disappointment. It was almost superhuman and a telling indication of that of which men are capable if their dedication is to creative work and knowledge instead of cruder efforts to dominate and be known." And I think there's a lesson for all of us there. Thank you.